Welcome back, everybody. I have graded our test, so I hope you've had a chance to check it out. You will want to look at your results carefully to see which of the topics you got credit for. I brought some more of these checklists. Does anybody want one? I handed these out on the first day. I hope you still have yours. You are going to want one eventually. You can also print them out from the class website. No? All right, great. I thought everybody was going to want one. So I hope everybody is clear on the way the grading works. The test, some people got all 9 questions right. Some people got less than that right. And that's okay if you got less than that right. It means that you will have to get them right on a later exam. Anybody have any questions about the procedure? I hope that it's pretty clear. Remember, the goal is, we're having a test on the last day of class, and so in theory, it's possible that you could get all the checks by that point, and then you wouldn't have to take the final exam. The final exam will just be sort of extra cleanup to chance for you to do the ones that you didn't get yet. Yeah.
Are the topics that we got right online, or are we going to find out now?
No, it's in GradeScope. You can check your grade for the test. And you should look like question by question, and you'll see which ones you got right.
Okay, thanks.
Yeah. If there's any ambiguity, let me know, and I would be happy to tell you. I am keeping track of them all in a big spreadsheet, but you want to keep track for yourself, just so that you know which questions you have to answer on future tests. All right. Great. Let's. I want to talk some more about the IIA. Then we only talked for like 10 minutes about it before. There was a question on the test about it, which most people didn't do, which is what I expected. A few people did it and got it right. Several people did it and got it wrong, which is fine. After today, you should be able to do it and get it right. This is, so let's, for real this time, talk about the IIA. I did talk about it for real last time, but only very briefly. This IIA stands for Independence from Irrelevant Alternatives. This is all about irrelevant alternatives. And the point of the IIA is it says that if people make irrelevant changes on their ballots, then it shouldn't change the results of the election. So I will write the definition again here. So a system satisfies IIA when if there is a winner and then you change some people's ballots. So if there is a winner, then we change ballots. Without moving anyone past the winner. This is the important part. Without moving anyone past the winner. So that means people change their mind, but everyone who used to be below the winner is still below the winner, and everyone who used to be above the winner is still above the winner. This is referred to as an irrelevant change because nobody's actually changing their mind regarding the positioning of the winner. All right? So we imagine there is a winner, and then we change ballots without moving anyone past the winner, and then the results should be unchanged. This is what they refer to as an irrelevant alternative. That's when you change your mind, but just about the losers. Not you change your mind in a way which has nothing to do with the ranking of the winner. Yeah.
But when you say without changing anyone past the winner, that means that you just change the winner, or what? Like you're not moving anyone under the winner. But I thought it's moving just people under the winner, but the winner stays.
Yeah, not quite. So let's do an example, and I will try to address this. So this is an example that we did last time. I will just refresh your memory. If I have 3 people said A, B, C, and 2 people said B, C, A, And let's say I'm going to use the Borda. Borda. That's the one with the points, right? The points go here, 0, 1, 2. So if I count up the points, this is the original election. If I count up the points, A gets 3 times 2 plus 0, which is 6. B gets 3 times 1 plus 2 times 2. That's 7. That's 3 plus 4. And C gets 3 times 0 plus 2 times 1, only 2. So B is the winner, all right? Just to help myself out, I'm going to like circle the winner here just so that I can pay attention to who was the winner and who was not the winner, all right? And the kind of change that I'm talking about is we change the ballots without moving anyone past the winner, and B is the winner. So here, I'm going to ask, what if we change BCA becomes BAC? This is the kind of thing that I mean when I say we change things around without moving anyone past the winner. C and A were both below the winner. After the change, they are still both below the winner. All right. So this counts as like an irrelevant alternative change. But if you now add up the points, you'll see actually it does change the results of the election. So now, after the change, it looks like 3ABC, and then I changed the other one, 2. Now it says BAC. It used to say BCA. You see the effect here is that A is going to get a little bit more points, and because we're using the Borda, this will actually make it possible for A to win. So this time, now, the points go A gets, it's 0, 1, 2 as usual. A gets 3 times 2 plus 2 times 1. That's 8. B didn't move. They still get 7, right? It's the same thing. 3 times 1 plus 2 times 2. And then C now is getting straight up 0. And now A is the winner. All right? So this is an example where you can make one of these so-called irrelevant changes, but the winner actually did change. It's not so irrelevant in this case, right? Because in the original situation, B was the winner, but after making this change, A becomes the winner. All right, so here, the winner changed. So in this example, we have demonstrated, we've shown that Borda does not satisfy the IIA. Because we made one of these so-called irrelevant changes, that is a change which did not move anyone past the winner, but it ended up changing the results of the election. Does that clarify what you were asking me before? Yeah. We did not move anybody past the winner. Anybody else got questions about this? This is the basic idea of the IIA. Let me just say, in this example, this is a good change. So I will say this here, just a little commentary on what we just did. This here, this counts as what is so-called irrelevant. Since, remember, the rule is you don't move anybody past the winner. We didn't move anyone past the winner, right? But if you had moved someone past the winner, then it doesn't count. So, for example, if I said it was BCA and I switch it to CBA, this is not allowed in IIA, right? So this is not allowed for the IIA. Since in this case I moved the C past the B, right? And B was the winner. Since we moved C past B. On the test, the question about the IIA, I think a lot of people just decided to try it because there's no penalty for getting it wrong. The most people who tried it ended up making a change which wasn't correct in this way. If you move somebody past the original winner, that doesn't count as a change for the IIA criterion. All right, so that kind of a change is not allowed since we moved C past B, and B was the winner. That's the point. All right. I thought it might be fun to can we just together try to do the question that was on the test? See if we can make some better sense of it this time around. Like I said, some people actually got it right, which is great. So this was our test question about IIA. It said using the ranked choice. If this is my election, 40 people said ABC, 38 people said BAC, and 20 people said CBA. All right? Using the ranked choice, and your job is make a change showing that the ranked choice does not satisfy the IIA. There's a lot of jargon here. My apologies. There's nothing to be done about it. Make a change showing that the ranked choice does not satisfy the IIA.
Because B is the winner, the original winner, could it then be, for example, either in the middle row 38, changing A and C, or could it also be in the other rows A and C, or is that not possible?
Yeah, so what we should do is, first of all, decide who is the original winner, because that determines which one you're allowed to move around. Can we work that out? And then I will answer the question. So let's figure out the original winner, the OG winner. I was recently having dinner with some friends of the family who have a teenage daughter, like a young teenager. I thought this was really funny. I don't know if you will think this is funny. Somebody mentioned the phrase OG, and there was like a younger kid there who was like, what does OG mean? And the mom of this teenager said, it stands for original gangster. And the teenager said, no, Mom, it just means original. It doesn't stand for anything.
Yeah, that's what I thought. That's what I thought.
I believe it stands for original gangsta. Look it up.
How'd that get shortened?
Shortened? OG. It's an abbreviation.
No, I mean original gangster to original.
It's not shortened to original. It's shortened to OG. The O is for original.
Are you okay?
The G is for gangsta. Take a moment. Think about it. Go argue with your mom about it. There was a big argument between this teenager and her mom about what OG actually means. And she couldn't believe that her mom actually knew and she didn't. Anyway, I'm not just here to teach math. Who is the original winner here? All right, we got to do the ranked choice. So we do the rounds, right? Round one. I say A, B. The A has 40 votes in the top position. The B has 38. And the C has 20. And so in the first round, the C is eliminated. I hope you remember how to do the ranked choice. And then in round two, how do the votes go? The A, the B, well, just A and B, right? A has 40 from before, B has 38. These 20, which used to be for C, now they go to B after C is eliminated. So now A has 40 and B has 38 plus 20, which is 48. And so B wins. All right? Oh, you know what? I'm sorry. I was, maybe you noticed, I was kind of confused in the back of my mind. It's because I wrote this wrong, sorry. It's ACB. I did it right on the test. I copied it wrong this time. Sorry about that. If you've been trying to work this out ahead of me, you realize something was messed up. Anyway, B is the OG winner, right? So that's just to help myself out. I'm going to circle them. And now, look at the arrangement of the winner and the other voters, and you have to ask yourself, what could I change around in order to change the results? But I'm not allowed to move anybody past the original winner. So what that means is, looking at these three columns, you cannot make your change over here. because B is the winner, the only way you could change these guys around is if you move the A up past the B or the C down past the B, and that's not allowed. Okay, so you cannot change this one. So let me just, I'll just try and go through my thought process, right? CBA with B is the winner. This actually can't be changed. If I want to do one of these irrelevant alternatives, you cannot make a change here because any change here would involve moving somebody up past the B or down past the B. Yeah.
Where did you get 48? Yeah, it's 50.
Did I add? Oh, I added 38 and 20. It's 58.
Oh.
Yeah, sorry about that. I was distracted by my other more serious typo. 58. You agree with that? Yes. All right, thanks. Okay, anyway, so that column you cannot change. So don't try to change it there. You should focus on these two. I could swap the A and the C here. That would be legal. I could also swap the A and the C here. But remember, I want to do this in a way which will actually change the winner. It seems to me changing the A and the C here, you could do that, but actually that will not affect the results of the ranked choice at all. Because B will still be on top there, and B is still going to win the election if I use ranked choice. So you should look to here. If I swap those two, then at least it seems like maybe C will end up being the winner. And so that's my idea. So here I'm going to say, I'm going to try to narrate all of my internal monologue here. You could do BAC, this is what I said before. BAC, the middle column, becomes BCA. Right? But this won't change the winner. Because it still has B on top. This won't change the winner. So the correct choice would be in the first column. We should do, what did it say? ACB. And I'm going to change this to CAB. Right? This is the change which is going to work out. Now, you have to actually check, does this actually change the final results? So, I say now, after the change, it looks like this. 40 people in the first column. Now it says CAB. The middle column was 38. What? 38 said BAC, like they did before, and then 20 said CBA. And now I do the ranked choice again. So this time in round one, I have A actually gets 0 votes, then B has 38, C has now 60. Right? Nobody put A on top, and C is on top 60 times. So A is eliminated in the first round, and then round two actually looks exactly the same. B still has 38, C has 60, and now C wins. And we have changed the winner by making one of those irrelevant changes. So this is what you had to do for a successful answer to that question on the test, which if a few people got it right, congratulations to you all. No shade on the rest of you, though. All right, I got all the lingo. No cap.
Fax no printer.
She's got it too. All right. If only that were on the test, right? Okay, let's talk about which of our systems satisfy the IIA. Actually, almost none of them do. So this example here demonstrates, well, what we said before, like the first example that I did today, was BORDA does not satisfy the IIA. Also, ranked choice does not satisfy the IIA. That's the one that we just did, the one that was on the test. All right. These do not satisfy the IIA. On the homework, I'm going to ask you to demonstrate the same thing for plurality. So also plurality. So if you're keeping track on that chart here, the chart, remember, had plurality. Then I think this is the way I ordered them. And then dictatorship. And the IIA column there should have mostly X's. Plurality does not, the ranked choice does not, the BORDA does not. What about the Condorcet? Actually, it turns out the Condorcet method does satisfy IIA. I'm going to try to convince you of that. So I'm going to put a check here, and then we'll also think about the dictatorship. Actually, I decided I'm going to put the dictatorship on the homework. Turns out the dictatorship does satisfy, because the IIA is all about if you change something here, it doesn't change the results. And if you think about it, the dictatorship, most changes you make don't change the results in the dictatorship anyway, because the dictator is still going to choose the winner. So this and this are on the homework. The next homework for next week. All right. Let's talk about Condorcet. Condorcet's method does satisfy the IIA. Can we explain why? This is one of those things, if you want to explain why, you have to say there's a certain kind of a structure to your explanation. You should say something like, let's imagine that there was a winner, and then I make a change which doesn't move anybody past the winner. So I will say something like, imagine X is the winner with the Condorcet method. And then we change the ballots. Without moving anyone past X. Without moving anyone past the X, right? X was the winner using the Condorcet method. Remember, that means that X wins all of its individual pairwise matchups. And if you change ballots, but you don't move anybody past X, that is, everyone who used to be under X is still under, and everyone who used to be over X is still over, would you agree that actually this cannot change any of the pairwise matchups? Is that a question?
The reason for that is that you're not it's all about pairs and how how the votes do compared to that winner. So if no one's surpassing the winner, then no one can overtake them overall.
Yeah, right. The whole thing about Condorcet method is it's all and only about the pairs. And if you didn't move anybody past X, that means the results in all the pairs is still the same. Everybody who was beating X before is still beating X. Everyone who was under X before is still under X. So we change ballots without moving anyone past X. Then I will say all pairwise results with X will be unchanged. And so the results don't change with the Condorcet method. And that's why the Condorcet does satisfy the IIA, because if you make one of these changes, it still don't change the results of the election. All right. Yes?
I have a question, but about the test and checking it off.
Okay, sure.
If the question on the test is please explain why Condorcet's method satisfies the majority criterion, and you get it right, do you check off the majority or the Condorcet?
Yeah, it depends. Each question was labeled with a A1 or whatever. If you look at right at the beginning of the question where it's written.
I'll find it.
Yeah, each thing on the checklist has a little abbreviation to it, and every question I wrote specifically which one it's about. If you have your test paper, you'll see it on there. Or I think she's going to find it. All right. So anyway, this is the Condorcet method and the IIA. All right. So the IIA actually is very difficult to be satisfied. Most things do not satisfy the IIA. In terms of the ones that we've talked about, it's just the dictatorship and the Condorcet's method. All right. I think it would be. I would like to talk for a bit at this point about all of the sort of the big chart overall, right? I don't care. Maybe I will write down all of the chart. You should have this in your notes already, but I will just real quick here, reproduce the rest of the chart. We had the majority criterion, we had the unanimity, we had the Condorcet winner criterion, the monotonicity, and the IIA. I think this is what we talked about so far. And the checks and the X's, they go, let's see if I can remember. The plurality is a check for majority. And monotonicity and unanimity, but not the others. I just want to look at the chart overall and make some comments about this. The rank choice does satisfy the majority and the unanimity, but not the others. Am I right? I think so. The Condorcet, actually the Condorcet satisfies all of them. This is quite remarkable. The Borda satisfies almost none of them. It does not satisfy the majority. It does the unanimity, not this one. Yes, that one, not this one. So it's like that. And the dictatorship, not the majority. Yes, the unanimity, not the Condorcet. Yes, the mono, and yes, this. All right, I think I got this right. This is the chart. All right. From the point of view, I think I've said this before, but from the point of view of the chart, just if I just ask you, like, okay, based on the chart, which is the best voting system overall? It's not really possible to say. Although you could say the Condorcet is pretty awesome because it has a check in every position. But actually, there is one major flaw. Like, why? Anybody remember? Why is it that why don't we use the Condorcet in real life if it's so awesome?
Because it's often that there is no.
Yeah, right. Because the Condorcet often does not choose a winner, and this is why it's not practical to use in the real world, because it's not okay to run your presidential election and then you just say, oh, well, I guess there wasn't any winner. That's not a good outcome. So this, remember, this is not usable. Otherwise it looks awesome, right? But this is not usable since it doesn't always choose a winner. Okay, so other than that, which one's the best? Well, you could say, oh, just like count up the check marks, but actually that's not a great way to go about it because, for example, the dictatorship has 3 check marks, which is the same as the plurality, and but the dictatorship is not a better, more democratic system. It's just the fact that these particular measurements happen to be checked off for the dictatorship. It doesn't mean that it's better. It just means that it obeys these kinds of specific mathematical properties. The big question that we could ask ourselves is there some system, maybe that we haven't discussed yet, but some imaginary, really super awesome system that's not one of these apparently, but is there a system satisfying all of these properties which actually does choose winner every time? You know, the Condorcet does, but that doesn't count. Is there a system satisfying all of these which chooses a winner every time? I wrote choices, which chooses a winner every time. This would be like the best possible, best imaginable system for voting. The answer to this question is, unfortunately, no. This has been studied by mathematicians for a while. The answer is no. And actually, there's sort of a famous, I don't know, it's not famous in ordinary sense, but among mathematicians, there's a famous theorem about this that I want to tell you a little bit about. This is called Arrow's impossibility theorem. And you can tell your friends about this. This is actually kind of the OG mathematical theorem about voting. There had not been serious mathematical work done in the area of voting until Arrow did this theorem. This is like in the 1950s that Arrow is the name of a person, and he proved what we now call Arrow's impossibility theorem. And you can tell your friends about this. The short answer, or the short sort of slogan, the tweet length version of Arrow's impossibility theorem is that no perfect voting system exists. any system that you could possibly imagine will automatically fail one of those criteria. And it's actually pretty striking. So I'll tell you specifically what Arrow's impossibility theorem says. It says the only system satisfying unanimity and IIA is, anybody fill in the blank here? Actually, you can see on the chart. There's only one system. I don't mean only one on the chart, but just anything you can imagine. There's only one system that satisfies unanimity and the IIA.
Condorcet?
Okay, not counting that because that doesn't always choose a winner. I should say that. It's the dictatorship. So you could say that the sort of short version of this theorem is just that no perfect voting system exists. Or if you want to be a little spicier take about it, you could say sort of what this means is like the only theoretically perfect voting system is the dictatorship, which is obviously not a good system to do in the real world. All right, this is Arrow's theorem. The only system satisfying unanimity and the IIA is dictatorship. And I will just say again, Condorcet method doesn't count because it often doesn't choose a winner. All right. This theorem, it's called an impossibility theorem because it mathematically has demonstrated that it's impossible to find a perfect voting system. This is something that's often misunderstood. What the theorem does not mean like we have not yet discovered a perfect system. It doesn't mean we just haven't thought of the perfect system yet. Actually, Arrow proved there can be no possible system like that. So it is a logical impossibility for there to be a perfect voting system. People in common parlance say like, well, you can't prove a negative, right? In mathematics, yes, you can prove a negative. So this is what Arrow did. He proved that there can be no perfect voting system. No matter how hard you think about it, it's not just that we haven't discovered it yet. It's that it really cannot possibly exist. This is sort of the ultimate bad news in terms of voting in the real world. It means real world voting. You have to choose a system to use, but every system has its own problems, and you cannot get around mathematical problems with voting systems. All right? Tell your friends, tell your mom's friends about Arrow's impossibility theorem. It's kind of an important theorem. Arrow, actually, the guy Arrow ended up winning the Nobel Prize, not for this, but he was an economist, but he was interested in mathematical economics, and he liked to write mathematical proofs of things, and this was a famous thing that he came up with. All right. Any thoughts about that? Arrow's theorem. It's bad news for democracy, I suppose. But this is the kind of it's in the same kind of spirit of the famous quotes where people say things like democracy is the worst system of government except for everything else that's been tried. It's like democracy is not perfect. It's just the best that we got, and you got to just sort of do your best with it. You can't make it perfect. All right, that's my hot take. It's not really my hot take. That's just it's a mathematical fact. Okay, I got one more criterion that I want to talk about, and then that will do it for our talk about voting. We may have one or two more things to say next time, but this is pretty much the end of our discussion of voting systems. We're not going to add anything more to the chart, for example. Okay, one more criterion, which I suppose you could add this to the chart, but for reasons which I will explain, we're not going to. Another criterion is manipulability. This is the next thing on the checklist, I believe. This is on the checklist. I call this A10. Every one of them has a little number. A10, manipulability. This is another thing about voting systems which we would like. In this case, we want to avoid a voting system which is manipulable. So I will say it this way. We don't want our system to be what we call manipulable. That is to say, well, I'll just say, in other words, it should be impossible to game the system. One thing that you worry about is if we invent some kind of mathematically complicated voting method, one problem with that is that people might analyze the mathematics and realize there's some kind of hacks that they can do by voting in some kind of weird way, which will have some weird mathematical effects. And this we want to avoid. So what I'm saying here is it should be impossible to game the system with some sort of mathy tricks, right? And if you make your system very mathematically complicated, then you might feel like that this introduces opportunity for people to game the system with some kind of pro gamer strats, where they can vote in a weird way, which has a weird effect. This is undesirable in the real world. And this actually is one of the things that people like about plurality. Even though plurality is very simple, that is actually a good thing in some ways, just because everybody understands how it works, and everybody understands how if I vote this way, this will be the effect of that vote. All right. More complicated systems might have a problem with this kind of thing, manipulability. So what I mean very specifically, we have to be specific about exactly what I mean by this, gaming the system. I'm going to say it this way. So gaming the system, for our purposes, what this means is voting in a way that's different from my true feelings in order to get a better outcome. For me, all right? This, for our sake, or for the purposes of our conversation, this is what counts as gaming the system. When I say that, what I mean is when somebody has an idea in their mind of how they truly feel about the candidates, but they decide for other reasons, for mathematical reasons, they decide to vote in a different way because they think that their vote is going to count differently if I vote some other way, all right? It means voting in a way that's different from my true feelings in order to get a better outcome for me. All right, this is also, like in the real world, people talk about this fairly often. This is sometimes referred to as strategic voting. And sometimes this is called a voting manipulation, because you are somehow working the system to make your vote count in a different way than it's intended. This is a voting manipulation. All right. This is undesirable in a system like a perfect system. We would like, I would say in the real world, we would like for our systems to be non-manipulable. That is, it's impossible to game the system by voting in a weird way. All right, if you're using a system that's actually manipulable, it means when people have to think about, oh, who am I going to vote for? Not only do I think about who do I want to win the election, but then I also have to think about what's my best strategy to make that person win the election. And depending on the system used, I might have a strategy which involves ranking the people in a weird order. All right, so this is undesirable. In the real world, you want people to just decide who they like the best, and that's who they vote for. Not I decide who I like the best, and then I think about the best strategy, and then I vote for the best strategic vote. All right, so we want our systems to be non-manipulable. Let's just talk about our various systems then. Is it possible to get a better result by voting in a way which is different from your true feelings? That's what I would like to talk about. So let's consider plurality first of all. I just want to talk through some examples about, are there strategies in the plurality system, or is it best in plurality to just vote for your true feelings all the time? Plurality, check it out. Plurality actually is manipulable. This is bad news for plurality. It is manipulable. What I mean by that is sometimes it is better to vote differently from your true feelings. You will get a better result if you vote differently from your true feelings. We can just look at the old Bush-Gore-Nader example. Remember that one? The Bush-Gore-Nader example. One of my all-time favorites. If you recall, we had 2.9 million people said Bush-Gore-Nader. I know we haven't talked about this in a while. 2.9 million other people said Gore-Bush-Nader. And then 0.1 million people said Nader, Gore, Bush. And with plurality, you count up who's on top. Bush got 2.9 million, Gore got 2.9 million, and Nader got 0.1. And the winner was Bush. They were slightly more when you look at the, I rounded off these numbers. If you look at the true numbers, Bush's numbers were very slightly more than Gore's, and so Bush wins. As written, it looks like a tie, but in the real world, of course, Bush was a winner. I would like to look at this. Is it possible for somebody to vote differently to achieve a better outcome in their mind? So this is also about changing people's ballots, although it's different from IIA, and it's also different from monotonicity. I'm going to, just because I like to, I'm going to circle the winners again. The question I'm trying to ask is, can someone change their mind Can someone change their vote to get a better result? By better, of course, I mean in their own opinion. Can anybody see? Looking at these columns here, ask yourself, if these people had changed their mind or changed their vote, could they have achieved a result which they like better? So actually, the first column, it's not possible for these people to get a better result. Their favorite was Bush, and Bush was the winner. So they already got the best possible result. You should be looking at these two columns here. Can either of these two people change their mind in a way which makes the result better in their own opinion? Yeah.
Nader voters could vote Gore to notably get a more favorable candidate.
Yeah, right. These Naders, if they had put Gore first, then Gore would have been the winner, and that is preferable in their own opinion. I'm not saying this is better outcome in the real world in some abstract sense, but I'm saying it is a better result in their opinion to make Gore the winner instead of Bush, all right? As is, their last choice was the winner. This is not good. They could have done better by changing their vote. So, can someone change their vote to get a better result in their own opinion? Yes, the answer is yes. In this case, the Nader, Gore, Bush can change to Gore, Nader, Bush. All right? Then the result is, well, we would redo the plurality with that change. So now it says 2.9 million say Bush, Gore, Nader, 2.9 say Gore, Bush, Nader, and the 0.1 say now Gore, Nader, Bush. All right? When you're doing the manipulations, you can change the votes however you want, all right? It's not like the IIA, you're not allowed to move anyone past the winner. The monotonicity, you change, but you always boost the winner up. When you're talking about manipulations, they can change the votes in any way that you want. So now, the results are Bush gets 2.9 million, Gore gets 3.0, and Nader gets 0, and Gore wins. And so let me just say now Gore wins, which is a preferable outcome to the Nader, Gore, Bush voters. All right? Again, I'm not saying that, Gore winning is preferable in the real world. I'm not trying to tell you my own opinion. It's just in their own opinion, they would have got a better result if they had voted differently. All right? That's what manipulation is about. It's about when you vote in a way which is different from your true feelings in order to get a better result. Actually, this is baked into the plurality system at all times. I've said in the past that I don't really like the Republicans, and I also don't really like the Democrats. But when I go to vote, I always vote for one or the other of those, because I understand that my vote doesn't really count for much if I vote for my mom or somebody else who I think would really do better than Biden or Trump. I think my mom would be better. I don't know actually if that's true. I don't know if my mom watches these videos, but she would be a fine president. But anyway, I don't vote for my mom. The reason is because that makes my vote mathematically worthless. My vote actually counts better if I actually vote for the Republican or the Democrat. All right. So that is a manipulation that we all do. Everybody who's voting in these elections in the plurality system is doing that in the back of their mind. It's not just who do I think is the best, but it's who do I think is the best who also is capable of winning the election, and that's who I vote for. All right. Let's talk. So this was an example in plurality. So the plurality system is manipulable. That's what I said at the beginning. All right. This is bad news for the plurality system. Let's talk about some of our other systems. How about the ranked choice? Is this also manipulable? I've said before, I kind of like the ranked choice in the real world. Is the ranked choice voting manipulable? The answer, unfortunately for me and other people who like the ranked choice, the answer is yes, it is. All right, let's try an example of that. So this is not the Bush coordinator. This is just another made-up example. This might be a nice little, test question. I'll give you some questions like this on the homework too. If I have an example like this. All right, so this using ranked choice voting. If this was a test question or a homework question, I would say something like, show how some of the voters can manipulate the result. And what I mean by manipulate, all right, manipulate here is sort of a technical term. It means changing their mind, voting differently to get a better outcome. All right, so this means change their mind to get a better outcome, better in their own opinion. All right, manipulate does not just mean you change your vote and that changes the results. It has to be you change your vote and that changes the results to be improved in your own opinion, to get an improved result. All right. So how will you think about this? First of all, you have to decide who the original winner is. Or do you have an answer?
I believe the original winner, if I'm doing this correctly, is so A wins. So B is eliminated in the first round. I think it is.
Let's work out the rounds. Yeah, you can probably do this in your head if you really tried to, but there's not much reason to try and do it in your head. So in the first round, we have A, B, C. You just count up the top positions. A has 6, B has 3, C has 4, and so B is eliminated in the first round. The second round is just between A and C. I hope everybody is hip to the ranked choice. Just between A and C. A is on top the first 6, but I believe C is on top for the others, which makes 7. So A has 6, C has 7. And so C is the original winner when I do the ranked choice. As usual, I'm going to circle them in the original chart. They are the winners. And now we want to think about, can somebody here change their mind to get a better outcome for themselves? Now, to me, I'm going to look, just look at each column. First of all, these ones in the middle, they already got the best possible outcome. So they are not able to manipulate because they already got the best possible outcome. Manipulate means you change your mind to get a better outcome for yourself. All right? These guys cannot. These ones maybe could. Their second choice one, maybe they could change their vote in a way that makes B the winner, but they already put B on top. The only way they could do that would be to move B lower, which seems a little sus, as they say. I'm just full of them today. This is how my kids talk. What about this one? Here, their last choice one. Do you see how they could change things around?
Yeah, they vote have A, B, C, so then, specifically B would get more votes and so B would get more votes and they would go in with, 9 versus, C's 4, and then they would specifically keep the 9 while C
Yeah.
stays with 4.
Yeah, right. I think these guys here, they got their worst possible result, but if they had put the B on top, then I think they could have made B a win and get their second place, which would be improved. So let's just verify that. She just talked it through. So here I'm going to say the ABCs got their worst result because C was the winner and that was their last choice. So maybe these people should have done better, or maybe they could have done better by putting B on top. That's the idea. So maybe they should try instead BAC, all right? Still leaving C on the bottom because they really don't want C to win, but if they go BAC instead. So I'm going to write that, the whole chart again, but including that change. So this was the first column. Let's say they went to BAC instead, and then the other two stay the same. CBA in the middle, and 3 people in the end say BCA. All right, and now we do the ranked choice again. So this time in round 1, A has no votes on top. B has now 9, C has 4, and so A is eliminated. And then in round 2, the votes are the same once you get rid of A because A wasn't on top at all. B is 9, C is 4, B wins. And that is a preferable result because now these people, the ABCs, they got their second choice to win instead of their last choice. All right? So B is preferable to the ABC voters. So they got a better result. All right? This is manipulation. Yeah.
So before you do all this, you have to look who you want to win, and then you change it. How do I know what the personal preference is?
Yeah, right. So it depends on what their original vote is here. So they liked A the best, and then B, and then C. So the person who actually won was their last choice. So B is preferable to them. Is that what you were asking?
Why not A?
Oh, A would have been even better. But actually, these people, it's impossible for them to change their vote to make A the winner. But so for them to improve the results, they could have made A the winner or B the winner. But actually, mathematically, it's not possible for A to be the winner. So B is the best that they can do. But it's still better than their original result. All right. So the plurality is manipulable. The ranked choice is manipulable also. It turns out, actually, I don't want to go through all of our different systems because there's another theorem about manipulability. And this one has this is also named after people. This has a fancier name. This is called the, these are two great names. Gibbard and Satterthwaite. This is the Gibbard-Satterthwaite theorem. You can tell your mom about this one too. The Gibbard-Satterthwaite theorem. It's Valentine's Day. Tell your sweetheart about Arrow's theorem and the Gibbard-Satterthwaite theorem. This is about manipulability, and it just says the only non-manipulable system is, anybody want to guess? The plurality is manipulable. The ranked choice also is?
Dictatorship.
The dictatorship, yeah. This is actually the punchline in a lot of the theorems about voting. The only non-manipulable system is the dictatorship. That means no matter how you do voting in the real world, it is always possible for people to work the system by voting in a way which is different from their true preferences. All right. This is another sort of bad news impossibility theorem about voting. This theorem, actually, the Gibbard-Satterthwaite, we've been talking about the Borda all along, although I think I've mentioned before, almost nobody uses the Borda in the real world, like in actual political elections. The Borda is basically never used. It's used for other kinds of things. They use it in Mario Kart. But in politics, nobody ever uses the Borda. The reason, actually, there's a reason. I don't know if you remember. I said I was going to tell you the reason eventually. The reason has to do with manipulability. So the Borda is regarded as extra manipulable. It turns out the Borda, very weird things happen when people vote strategically. The Borda is super manipulable. And this is the principal reason why people don't do Borda in the real world. And actually, this was known by Mr. Borda himself, the guy who invented this. Somebody raised this as an objection to his system, and his famous quote was, who cares? His quote was, "My system is intended only for honest men." This is because Borda is super manipulable, and if people vote differently from their true feelings in Borda, then you can arrive at ridiculous outcomes. And I wanted to just give a quick example of that. So Borda is super manipulable. What I mean by that is that insane things will happen if everyone tries to vote strategically. All right. I would like to talk about this. Let's just look at in the context of the Bush-Gore-Nader election. I will write the numbers again. 2.9 million say Bush-Gore-Nader. 2.9 million say Gore-Bush-Nader. And 0.1 million said Nader-Gore-Bush. I would like to think about if we're using the Borda, and these voters all voted strategically rather than according to their true feelings, but they try to vote with a strategy, then what would the votes look like? Using Borda, there is a very simple strategy that everybody would use. The strategy is, in the Borda, when you vote for people, they get points according to your vote, right? The last place is 0 points, the next place is 1, and the top place is 2. All right? What's the strategy that people will do in the real world? Actually, you don't have to tell people to do this. They will do it automatically. You have an idea?
Yeah, they put their least favorable candidate in 0 one day.
Yes. Well, yeah, they put their least favorable candidate at giving them 0 points. I would say it a little bit more subtly than this. Like, actually, I think if we did this election in the real world, these people, knowing that Nader doesn't have a chance of winning, these voters actually would put Gore all the way at the bottom and put Nader in the middle. That's because Gore is the true threat in this election to these voters. They want Bush to win, but they realize that Gore might win instead. And so they are going to dump Gore all the way to the bottom and put Nader in the middle. Nader is not a true contender, and so giving Nader 1 point is not a big deal. They don't want to give Gore any extra points, so they dump them down to the bottom. All right. So this is the strategy that people will actually do this if you use Borda in the real world. The strategy is to dump. This is called dumping. Dump your most serious rival to the bottom. All right.
Is the last column on purpose
NGN, no, sorry. That should have said NGB. That's how they, yeah, thanks for noticing. All right. Using the Borda, the strategy is to dump your most serious rival down to the bottom. That's because you don't want to give them any points. You have to imagine someone who's like in our last presidential election, someone who is, I'm going to vote for Biden and I really hate Trump. they are not going to put Trump into second place. They're going to put Trump all the way at the bottom, even if, even if like Satan is on the ballot. Yeah, I'll put Satan up there because I know Satan's not going to win. Maybe I'll throw Satan a few points, but I do not want to give any points to Trump because he might actually win, and I want to dump him all the way to the bottom. This is the strategy that people will use when you're using the Borda, all right? The strategy is to dump your most serious rival to the bottom. Okay, so can we look, yeah.
Yeah, so just to clarify, it's not necessarily who you hate the most, just who might beat your candidate.
That's right. Who you think is going to win. Yeah, right. You might actually move somebody up who you really hate because you know they're not going to win anyway. You throw them a few points. All right. So let's think about how would this election have gone if everybody votes according to this strategy here. So doing this strategic voting. Strategic voting would be like, so like I said, this first column, the Bush-Gore-Naders, they would have gone Bush, Nader, Gore. That's because they know Nader is not a real contender. Obviously, Nader never is going to come close to winning here. So we can throw Nader a point, even though we don't actually like Nader. We throw Nader the point. The purpose of this is to make sure that Gore doesn't get any points. All right. What about the next candidate, the Gore-Bush-Naders? How would they have voted? Yeah, what do you think?
Gore, Nader, Bush.
Gore, Nader, Bush, yeah. Now, in real life, actually, the Gore voters, they might actually like Nader a little bit. But the point is, they really don't want Bush to win. They recognize that Bush might win, and so they're going to put Bush all the way to the bottom. All right? And then the last people, the Nader, Gore, Bushes, actually, I would say they probably are going to keep their vote the way it is. They already want Nader to be the winner. They don't mind giving Gore points because Gore is kind of their second best anyway. So actually, there's no incentive for them to change their mind at all. These guys, the point ones, they will probably stay like they are. They already have they're giving Nader the most points already. So, okay. Anyway, can we see what the results are now? So this time the results go. All right, Bush gets 2.9 times 2 in the first one. The next one is a 0, and the last one is a 0. This is 5.8 million points. All right, that's the Bush results. The Gore gets 0 in the first column, 2.9 times 2 in the next column, and then 0.1 in the last column. This is actually 5.9. Gore is doing a little bit better. And then the Nader, we always got to consider the Nader. That's a 2.9 times 1 in the first column, plus a 2.9 times 1 in the next column, plus a 0.1 times 2. You add this up, it's an even 6.0, and the winner is Nader. Can you believe it? No one ever expected Nader. Nader wins. All right. The moral of the story is, this is what I said before here. Insane things happen if everyone tries to vote strategically in the Borda. This is why people don't use the Borda in the real world, because everybody will monkey around with their votes and it will make Nader win, which is almost nobody actually wanted Nader to win. But strategic voting in the Borda causes ridiculous results to occur. And this is why the Borda is not used in the real world. All right. That's the last thing I wanted to say about manipulability. Any thoughts about this? This is the principal reason why we don't use Borda in the real world, because if people are allowed to vote however they like, they will change their votes around in weird ways, which will cause the results to be weird. It's no problem, using Borda type schemes for like adding up points in the World Cup. This is how they really do it in the World Cup, depending on wins and losses and ties. But there's no concern. Well, I suppose there's a fair amount of corruption in the World Cup, but there's not really opportunity for people to manipulate their wins and losses to monkey around with the point values. So in sporting type things, the Borda works just fine. All right. We got 10 minutes left. I don't think that's enough time to totally finish it, but I got one more thing to say about voting systems before we move on to something completely different. I don't know if you're starting to get bored with this voting system stuff. It's almost over if you are. This is on the, oh, sorry, I had two more things. The last one thing is very simple, but this is topic number A11 on the sheet. This is actually one of my favorite voting systems, although I wouldn't really say we should use it in the real world for the president or something like that, but this is called the random dictator method. This is something that sounds ridiculous when you describe it to people, and when I describe it to you in a moment, probably it will sound ridiculous, but the more you think about it, the more actually it makes a whole lot of sense. This is the random dictator method, all right? It's like dictatorship. Remember, dictatorship is one of the voters ahead of time is chosen to be the dictator, and then just like whatever they say becomes the real result, and everybody else's vote is ignored. Random dictator is like that, but the dictator is chosen randomly after the votes are cast, all right? Another way of saying this is everybody votes, and then one ballot is chosen at random. So it's like you vote, you put all the votes in a hat, but then instead of counting out all the votes one by one, you just pick out of the hat one at random. And then whatever that one says, that's the winner. Everybody votes, one ballot is chosen at random, and then that ballot determines the winner. This is called the random dictator method because it's as if as soon as you choose that one ballot out of the hat, that ballot becomes the dictator and none of the other votes matter anymore. It's just the one that you picked. This is the random dictator method. This sounds like a ridiculous notion, but actually this works really well in a lot of different situations. So I will say this sounds crazy. I think just because of the randomness, it sounds ridiculous, but actually works great in some situations. It has very nice mathematical properties. For example, if I ask everybody here, you know, what's your, I don't know, let's say we're voting for the president. Let's say I just asked everyone to vote for Trump or Biden. Put all the votes in a hat. Rather than counting them out and deciding who wins that way, I just choose a vote at random out of the hat, all right? Think about this. What if 60% of you voted for Biden and 40% of you voted for Trump? You can think about what are the chances that Biden is going to win when I pick the vote out of the hat? The answer is 60%, like whatever the percentage is, when I pick the vote out, it will be the winner with that same percentage. So I'm going to say what's great about this is something like if X% of the voters vote for some outcome, then the probability of that outcome is actually X%, right? This makes some kind of sense, in my opinion. If the population has a certain opinion, then that opinion is actually realized with the same probability that it ought to be, all right? This is different from, so for example, I'm going to say this is, I will say this works really well for repeated votes. For example, let's say you live with two of your friends, and this every Galentine's Day you decide to go out with your gal pals, and you have to decide what restaurant you're going to go out to, and two of you really love McDonald's and the other one wants to go to Panera or something. Now, if you're going to vote for this, like let's imagine you're going to go out every night and you say, okay, girls, let's vote again. The McDonald's are going to win every time because 2 of them like McDonald's and 1 of them likes Panera, all right? In that situation, if you're going to go out every night and you have to decide every night, I would say voting is not a good way to make the decision because the 2 McDonald's are going to win every time, all right? It would be better if there was some method where the 2 McDonald's would win 2 out of 3 times, but you get to win 1 out of 3 times, all right? And actually, this random dictator method will work exactly like that, all right? It is a statistically appropriate voting method to use when you're going to do something over and over again, but there's an imbalance in the opinions, all right? Just because 2 out of 3 people want to go to McDonald's doesn't mean they should get their way every time. It means they should get their way 2 out of 3 times. And that's how the random dictator method is meant to work. All right? I'll say a few more words about that next time, but maybe we'll leave it at that. Thank you for your attention. Next time we will move on to something completely different, if you're in the mood for that. Please look at your test results. Let me know if you have any questions. I would be happy to go over anything if you're not sure why you got it wrong.